Hi everyone, my name is Emilio. Today we're going to cover how to set up an LVM RAID 1 volume on a LUKS encrypted device. Now, when I was learning how to do this myself, I couldn't find an easy guide that showed me how to do everything I wanted to do in one place. I kind of had to gather different resources and figure out what exactly I wanted to do. So I'm hoping that if you're in the same situation as me, you find this guide helpful. A couple things to note. I'm creating this volume here to have a place to mount my home folder. So your use case may be a little bit different. If that's the case, just go ahead and modify the steps accordingly. Another thing to point out here is that my system is encrypted. So I'll be able to auto mount my RAID volume by keeping a key file on my system. Okay, so when I put in my password to unlock my system, the key file is going to be there to be read to unlock my RAID volume. Now, if your system is not encrypted, you can go ahead and have a key file on a USB thumb drive that you keep safe. That's fine, and that'll work. But you'll just have to modify your steps accordingly. Having said all that, let's go ahead and get started. So the first thing I want to do here is I want to go ahead and list the devices that we have. So we'll do that with the lsblk command. And you notice here we've got a bunch of devices, loop devices, and then SDA, SDB, and SDC. One thing I like to do is just to kind of make things a little bit cleaner for myself, is I add a flag to that, the -E7 flag. I apologize for all the sound there in the background. Got motorcycle guy going around. Okay, so lsblk, we're going to list the devices, but we're going to exclude the devices with the major number 7. Okay, so when we put that in, it gets rid of those loop devices. Looks a little bit cleaner. So as you can see here, SDA3, that's where the root of my file system is. All of my devices, all my files are on there. Okay, it's a LUKS encrypted device. I've also got SDB and SDBC here. These are 5 GB virtual disks. This is what we're going to create our RAID 1 array from. Okay, so the first step here is to elevate the permissions. Okay, so I'm going to go ahead and just type in sudo su and put in my password. This is going to switch me to the root user. I recommend doing this, otherwise you'll have to type in sudo before every single step. That gets old pretty quick. Just make sure that you're careful when you're acting as the root user. You exit when you're done. And again, just be careful with the commands that you put in. If you follow my guide, you're going to be just fine. So first command here is going to be crypt setup LUKS format. Now when typing in LUKS format, excuse me, when typing in LUKS format, you want to make sure you capitalize that F there. And the first device we're going to format for LUKS encryption is /dev/SDB. Let's go ahead and do that. Now it's going to say here, well, it's going to ask you if you're sure that you want to do this. It's going to overwrite all the data on /dev/SDB. Yes, that is exactly what we want to do. And it's going to have you enter in a passphrase. Of course, you're going to go ahead and just type in the confirmation there. And if you typed in both the same, after a few moments here, it will move on. Okay, so we've done that for /dev/SDB. Now we need to do it for /dev/SDC. Okay, same thing here. Let's go ahead and put in the password, and I recommend using the same exact password that you used for the other one. Not only that, but make it a password that you can either remember, or if you're smart, you're going to have a password locker like KeePass. You want to make it secure enough that nobody can get in, but not so secure that you yourself can't get in if you need to. Okay, so I formatted both devices for LUKS encryption. Next step, so crypt setup again. You might notice as we go through this that I'm pretty bad at typing. So crypt setup, this time we're going to do LUKS open, and we're going to take our first device here, /dev/SDB, and we're going to open it and we're going to call it LUKS-home1. And let's go ahead and put in my password. Now I don't think you have to guess very much or think pretty hard about what I'm going to name this next one here. It's going to be LUKS-home2. Make sure you're switching the device to /dev/stc. Same thing here. Going to put in the password, and we're good. So we've formatted these devices to use LUKS encryption. We've opened them up, so now we can use them. The next thing we want to do is we want to mark these devices as physical volumes that can be used by LVM. Okay, so the command we're going to use to do that is pv-create. So physical volume create. That's /dev/mapper. So when we open these devices before, they were mapped to /dev/mapper and then their name. So in this particular case, LUKS-home1, and then we've got another one here. I'm just going to go ahead and copy this. Work smarter, not harder. All right, and we're going to mark both of these devices as physical volumes. So I've done that, created the volumes, we're good. Let's go ahead and verify that. Type in PVS. That's going to list our physical volumes. As you can see, I already had one. I'm pointing at the screen. I should probably use my mouse cursor. I already have one called LUKS-ubuntu. That's part of the Ubuntu volume group. Okay, we're going to go over the volume group in the next step. So for our next step, we're going to create a volume group. We're going to type in vg-create, and the volume group, in my case, I'm going to call it vg-home. Okay, not very original. It doesn't have to be very original. And once again, I'm going to go ahead and copy and paste here. So I'm going to create a volume group called vg-home, and I'm going to add these two physical volumes to it. Okay, so now when I type in PVS and list my physical volumes, you can see they're both part of the vg-home volume group. Okay, next step here, kind of breezing through, we're going to go ahead and create the logical volume. So we've got two physical volumes, one volume group, and we're going to create one logical volume within that volume group. Okay, combining those two physical volumes together. So the command we're going to use for that is lv-create. Okay, logical volume create. Two hyphens here. We're going to type in --type. We're going to make this RAID 1. Okay, we're going to do -m space 1. So there's going to be one mirror. So the one device is going to hold the original data. The second device is going to mirror it. So there's one mirror. Okay, and here we're going to specify the size. Now, in the max I can do here is 5 gigabytes. Okay, if I wanted to make this logical volume 2 gigabytes, I would just type in 2 capital G. It's not what I want to do here. I just want to use all the space that I have. So I'm going to type in 100% free. Okay, -n. So we're going to name this, and I'm going to call my logical volume home. Again, pretty easy. Not getting really creative here. And I'm going to specify which volume group I'm going to be using. In this particular case, I'm going to be using the vg-home volume group. So let's go over that command again. lv-create, type RAID 1, one mirror. I'm going to be using up all the space that I have, so that's -l space 100% free. I'm going to name it home, so -n home, and then it's in the vg-home volume group. Okay, we're going to press enter there, and logical volume home was created. Okay, so let's have a look at our logical volumes. To do that, we type in LVS, and we can see here there's the root logical volume and the home logical volume that we just created. So what you should notice if we type in the PVS command is there's one less logical volume than physical volumes, and that's because we're using these two physical volumes here, and we created one logical volume out of them. Okay, moving on. We've got our logical volume now. Just imagine it as a hard drive you just bought from the store. okay? And it's got no data on there. As a matter of fact, it doesn't even have a file system. So of course, we're going to format the device for a file system. So in this particular case here, we type in mkfs.ext4, okay? So we're going to use the ext4 file system. It's not compatible with Windows, but LVM isn't either, so we're in no danger there. Okay, so mkfs.ext4. You may hear fireworks in the background. It's July 6th, so I guess we're not quite over that yet. So mkfs.ext4/dev/vghome/home. Okay, so this is the logical volume I created earlier. We're going to format for the ext4 file system. Oh, and I made a typo there. That should be /dev. It's going to take a moment to do that. And done. Okay. So the next thing we're going to do here, remember I'm creating a device to move my home folder to, so of course I need to move my data over to it. So what I'm going to do is I'm going to create a temporary mount point for that volume. Okay, so I'm going to make a directory with the mkdir command, okay, and we're going to make it at /mnt/home. Okay, I made that temporary mount point. Now let's go ahead and mount the device. So that's mount/dev/vghome/home, and we're going to mount that at /mnt/home. Okay, we've mounted the device. Now let's go ahead and access the device. So I'm going to change directory. I'm going to go there, and you really shouldn't see much of anything. There's a lost and found folder, okay, but there's nothing really there. So we're going to go ahead and copy the files over. So what I'm going to do is I'm going to use the rsync command. Again, we've got those, I'm sure they're beautiful fireworks in the background. So rsync, and then we're going to use the R flag. Now that makes it recursive. So we're going to copy over any folders, files that are within that directory, going all the way down. We're going to copy everything there. We're going to use the A flag to copy over the attributes. So if we don't put this in, you sync the files over, the permissions are going to be screwed up, and the owner of the files is going to be root, which means when you're trying to do anything on your computer, you won't be able to modify anything because root's the owner and really should be you that's the owner. So we want to keep everything the way it is. We're going to use the A flag there, and then we're going to put the capital L flag on there because we want to keep any links that we have. Okay, so we're going to copy it from the /home folder, and you really do want to make sure that you add this extra slash at the end there. If you don't, it's not going to sync to exactly the right place when you copy the files over. Just trust me on this one. Put that trailing slash there, /mnt/home. So once again, we're copying these files from your home folder to the temporary mount folder that we have there, and let's go ahead and copy them over. Mine was near instantaneous. I don't have any files in my home folder, so it may take longer for you if you've got a lot more files than me. Okay, so let's go ahead and set up auto mount. So we've copied the files over. We want to make sure when we reboot that these devices unlock themselves and mount to the correct place. So the first thing we're going to do here is we're going to type in crypt setup again. This time we're going to type in LUKS dump. Okay, and we're going to do the first device. That's /dev/sdb. Okay. So you get some LUKS header information, the version, all that good stuff. But what we really need here is the UUID, universally unique identifier. Okay. So I'm going to just go ahead and copy that and paste it, because this is going to come in handy later. And you can see here there's one key slot 0, that's the password. we're going to add a second key slot with a key file later on. So same command as before. This time we're going to do /dev/sdc. And the UUID for that is right here. Once again, I'm going to copy and paste. And we're going to use that in the coming steps. So let's go ahead and create our key file. So to do that, we're going to use the dd command. Type in dd space if equals /dev/urandom. It helps if I type that correctly. There we go. And then the place we're going to create it is, in my particular case, /root/ and I'm going to name it LUKS-home, home -- key file. I'll just call it key. Okay, and make sure you put these options here: byte size 124, count equals 4, and let me just look over that, make sure I typed everything correctly. Looks good. Okay, and as we can see here, it created that file, that key file. Now you want to make sure that you don't move it, you don't modify it in any way, because as soon as you change one bit on it, it's no longer going to unlock your system. So one of the things I like to do is I like to change the permissions on it. I don't know who else does this, but chmod 400, this is going to be read-only. Okay, so we're going to change it to read-only. Permissions cannot be modified, can be moved though. There we go. And this key file that we just created, we're going to go ahead and add that to our LUKS devices. So we're going to type in crypt setup, and then it's LUKS add key, and then we're going to take our first device /dev/sdb, and we're just going to go ahead and copy this here, paste. So to go over the syntax, crypt setup, LUKS add key. This is this is the device we want to unlock. This is the key that we're going to use to unlock it. It's in the root folder. It's called LUKS home key. Perfect. Now it's going to have you enter in the password that you created earlier for this device, and it's going to take a moment, but once it's done, it will be able to unlock itself with that key. Okay, so let's do the same thing to /sdc. Okay, so this is almost done, and let's go ahead and look at the information here. So now you'll see that there's two key slots. Key slot 0, that's the password that you created, and then key slot 1, and that's unlocked with the key that we created. Okay, so it's great that we have the keys, but now we have to tell the system to actually look for the keys to unlock the devices. Okay, so what we're going to do, you can use your text editor of choice. I like to use Nano for a simple thing like this. But you might use a VI, you might use Vim, whatever you want. I'm certainly not judging. /etc/crypttab. So we're going to edit /etc/crypttab. Open it up. As you can see here, I already mentioned before, my system is password encrypted. It's called LUKS Ubuntu. We're going to go ahead and add a couple lines here. So first line, and I'm just going to copy and paste this, and I'll put this in the description of the video. But as you can see here, the first device that we're going to put there is LUKS-home1. Okay, and we're going to copy this UUID. We're going to paste that right there. You may type it by hand. I would prefer not to do that, as you can see. And the device, the key file that we're going to use is located here. We got this part, and we're identifying it as a LUKS encrypted device. Okay, Now it's not enough to have just the one line there. We're going to add the second device. I'm going to go back, and I'm going to call this lux-home2. And let's go ahead and get the UUID for /dev/SDC. Paste that there. Now, you could type in /dev/SDB here, but if you were to plug in another device, or for some reason move these devices, and now SDB shows up as SDC, and SDD shows up as SDD, well, they're not going to unlock correctly anymore. So to avoid that, we want to use the universally unique identifier. And that's going to stay the same no matter where the device is plugged in. So we've got those both in there. We've told it where to find the key. We've told it that it's a LUKS encrypted device. We're good. Let's go ahead and save that. When you're using Nano, you press Control X. Ask if you want to save, press Y, press Enter to save it. Okay, we're good there. We need to edit one more file. /etc/fstab. Okay, and what we're going to add to that, again, I'm copying and pasting here, folks. I'm going to go down, and as you can see here, this line here tells you to mount the root device. This tells you how to mount boot, and this one I'm adding is telling you where to find /home. Okay. So we've seen this before, /dev/vg home/home. This is our logical volume, and home is going to be mounted to it. It's going to use the ext4 file system, and it's going to use these settings here. Now, don't ask me what exactly these settings do. I'm not an expert in that, so I wouldn't be able to tell you. So we're just going to go ahead and save that, and then this next step here, I believe, is optional. I don't believe you need to do it if you're mounting the home folder. I believe you only need to do these next two steps if you've modified the root directory in any way. I'm going to go ahead and do them anyway. But again, I believe you do not need to do this. And also, I don't think it's going to hurt anything either. So update -init ramfs. We're going to use the U flag. We're going to use the K flag. We're going to type in all there. And it's going to take a moment to update that. Once we're done with that, we're going to update grub as well. So we'll just give it a moment. A little bit longer than I remembered it being. Okay, and we're done. Let's go ahead and update grub as well. This is not going to take nearly as long. And before I finish the sentence, I'm sure it'll be done. Well, almost. Okay. So the next step is to reboot the system. So I recommend everybody just go back and check your files, make sure that you've typed everything correctly, /etc/crypttab and /etc/fstab. Make sure everything's right in there, because if it's not, when we reboot the system, you're going to end up with a system that doesn't boot if you typed something incorrectly. It's not, I mean, it is recoverable. You can fix it. It'll just be a little bit of a pain in your butt. So go ahead and avoid the trouble. Just go through the trouble to check those before you reboot. I'm confident in what I've typed, so I'm not going to do that. I'm just going to restart now. Now, I was actually SSH'd into a virtual machine that I've been running this on, so I'm disconnected. We'll wait for it to reboot. When it comes back up, I'll reconnect to it. And off screen here, in just a moment, I'll be typing in my password to decrypt the device. Now again, I'm decrypting the system here. Okay, the key file is on the system. So when that's decrypted, then my RAID volume is going to be decrypted as well. And we're just waiting for it. It's not the fastest thing in the world, but it does get the job done. Here. I'm going to try and connect. There we go. Okay, so we're back in there. So when I type in lsblk, that was the first command we put in when we started, and you're going to notice that it's pretty different now, the results that we get. So ignore these loop devices. We've got SDA. We've got our system here, but you'll notice that home is here, okay, on SDB and SDC. So again, this is a RAID 1 device. Whatever is written to one device is going to be written to the other one. So this is our logical volume, our volume group, and this is our LUKS encrypted device here. And home is mounted to that. We've still got all the files that we had before, which is to say just about none, okay? There's some hidden files, but you're going to find that on any system. So really that's that. If you follow these instructions, you should have a working LVM RAID 1 volume on a LUKS encrypted device. If you got stuck somewhere, if you have any questions, just go ahead and comment below this. I'll do my best to answer any questions you have. I'm no expert, but I'll see what I can do. Have a great day. Bye.